And today we're going to be talking about black holes and outer space. So we always do a couple different things during these meetings. We have an introduction so we can tell you why we're here and who I am. We will talk about our topic, which is black holes, and then we'll go over our homework activities and cover some extra resources for you to learn more if you're interested. This is relevant. So introduction, my name is Megan, and that picture is what I look like when I am dressed up for work. This is not work Megan, this is home Megan, but business Megan works at scientist.com, and I am Aiden and Lizzie's mom. So Aiden is joining us today, and I might work with your moms and dads at scientist.com, or maybe we're friends, or you're friends with my nephew Oliver for some of you. And I have a background in science. So I actually went to college to study different kinds of science, and I love it so much. I love to share cool facts, and I really like to teach. So we're doing this today because a lot of you guys are out of school, and you're going to be out of school for the rest of the year. So doing school from home, kind of like how all the adults are working from home. And because your moms and dads are still working, there's a lot going on for them, and it can be really hard to keep up with everything. So I thought I would try to help out and help you still get an education. And that's why we're chatting today. So now we're going to go ahead and we're going to talk a little bit about black holes. So some of you guys might be familiar with black holes. I didn't know a lot about them, so I got to learn a lot in this process as well. So the first thing we need to talk about is what is space and what is outer space? And you guys might remember from our weather episode that the Earth has different layers to it, and there's also different layers of our atmosphere. So the atmosphere basically starts right above the ground. So as soon as it's not solid Earth anymore, we're starting to get into our atmosphere. And our atmosphere is, filled with different gases. So like we're breathing in, and the atmosphere produces weather and things like that. And the part that we call outer space actually begins about 100 kilometers above the Earth. So you might remember that a lot of the weather that we see happens in the troposphere. Outside of that is the stratosphere, and then we get to the mesosphere, and then the thermosphere, and then the exosphere. And you can see in this picture of the exosphere, there's a little satellite hovering around in there, and that's where outer space is. And you can also see in this picture that there's a picture that's taken from outer space. So you can see the Earth, and you can see, some clouds and things kind of over it, and you can see the haze of our atmosphere, and then lots of different stars and things. And that is also outer space. So where the shell of the air that's around our planet, where that disappears, there's actually no air anymore in outer space. And so there's no air to scatter the sunlight and produce a blue sky like we see on Earth. And so that's why the sky appears to be black, and it kind of looks like a big black blanket, but it's dotted with stars. And the stars are way, way, way far away in outer space, miles and miles, millions of miles away. But we can still see little pinpricks of light from them. So you might be wondering if space is empty because there's no air in it. And actually, space isn't really empty like we think of it. There's lots of things out there. There's stars and there's planets, but even in the spaces between that, it's filled with huge amounts of thinly spread out gas and even dust. So space is actually dusty. And even the emptiest parts of space, they have at least a few hundred atoms or molecules kind of hanging out in there for each little section. And there's actually also a lot of other things in space that you wouldn't think about. There's trash in space. There's actually space junk. So as humans, we've sent stuff up there, like satellites and spaceships and probes and things, and sometimes parts break off of there or accidents happen, and it actually produces space junk. So there's kind of some trash hanging around up there. Every once in a while, one of those pieces of junk might re-enter our atmosphere. And while it's traveling down towards the Earth, it'll get super, super hot and heat up, and it'll actually burn in our atmosphere. And sometimes those look kind of like shooting stars in the sky. So the other thing to know about space is that it's also filled with some things we can't see. One of those things is radiation, and that's a form of energy, but it's basically an invisible ray that we can't see. And those kinds of radiation actually can be very dangerous for astronauts that are hanging out in outer space. So a lot of that is infrared or ultraviolet, and we can't see it. But ultraviolet radiation comes from the sun. And so you guys might be familiar with that because we need to protect our skins from UV radiation. So we might use things like sunscreen or maybe a hat or a parasol to block the sun and keep the UV from damaging our skin, because it actually can alter the way that our DNA that builds our structure, it can alter the way that builds new skin and cause issues. Infrared,
And
you
sunglasses.
guys might be familiar with that because it kind of produces some warmth. So if you can see in infrared, like some like bugs and animals, like snakes and stuff can see infrared, they can actually see heat sources. So those two kinds of energy are coming from our sun. And those aren't too bad, but there's also really, really high energy X-rays. And you guys probably know X-rays. You might get one if you have a broken bone so that you can see inside your body. There's also gamma rays and cosmic rays. And those particles are traveling almost at the speed of light. So they're moving super, super fast, and they come from very distant star systems. But they can be dangerous to astronauts, so they need to be careful about that. So that is kind of some of the background around black holes, but there's another really important topic that we need to understand before we can discuss black holes, and that is gravity. So you guys might have seen a picture kind of like this before. Does anybody know who that is?
Isaac Newton.
Yeah, that's Isaac Newton. So Isaac Newton is one of the first people that really explained gravity and kind of described it to us. So people really kind of might have known about gravity, but they didn't know exactly how to explain what was happening because it's invisible. So what gravity is that it's a force of attraction, and it pulls things together. So everything that we see and can't see, everything that we interact with is made of matter. And the more matter something has, so like the bigger it is and maybe the heavier it is, the greater the force of that gravity is upon it. So what that means is that really, really big objects like planets and like stars have a strong gravitational pull. So we right now are sitting on top of a very big planet, and that planet has gravity, and that's what is actually holding us down to the surface of the Earth. Do you guys have any guesses about what would happen if we didn't have gravity on the surface? Aiden?
Everyone would just float, and we'd have to like swim through the air.
Yeah, you're right. Because the Earth is spinning pretty fast, right? So we'd probably just fly off. Like if we were on a big hamster wheel and suddenly let go, we'd fly off. And we don't want that to happen. So it's really good that we have gravity, right? That's kind of holding us down to the surface, because at the core of our Earth is where kind of all that gravity is focused, and it's pulling us down towards the surface. And a picture of Newton is usually used.
Whenever this is over, probably by 2:30.
Hey, Chris,
So,
could you mute?
oh, I'm sorry.
That's okay. So in this picture, you'll see with Newton, you might notice that there's an apple, and he's like, ah! And the story is that Newton realized gravity was a force when an apple fell from a tree and might have bonked him in the head. And so he started to wonder about why that apple was attracted to the Earth, and he kind of described the theory of gravity. And the other cool thing to note about gravity, I'm going to show you on this slide, is that it's different depending on the size of the planet that you're on. So you might remember I just said that really, really big objects like planets and stars have a lot of gravity. Well, that means that smaller planets and moons and things don't have as much. They're not pulling us down as hard. So if you weigh 100 pounds on Earth, when you went to the moon, you'd only have a similar weight of 17 pounds, which is pretty crazy. So it actually is pulling you down less, and so you feel very, very light. But if you go to Jupiter, Jupiter is such a huge planet. It's actually, we call it one of the gas giants of our solar system. Jupiter is so huge that you would feel like you weighed 253 pounds. So you'd be 2.5 times heavier, and it would probably be really hard to walk, and you'd go really slow and be kind of squished down. So as you can see, as the planets are getting bigger, they have more gravity and pull us down harder. And as they're smaller, they pull us down less. So if you were on the moon, you could run and jump and play really, really easily. But that also means that the moon isn't holding you down to the surface very well. So it might be easy to kind of float away. So there's some pluses and there's some minuses to that.
There's no weather on the moon.
That's also a very good point. To have weather, you have to have what? an atmosphere. And if there's no atmosphere, there's not really any weather. So on places like Jupiter, where it's all made of gas, there actually is weather, because that gas is floating around the outside and it's swirling and doing different things. And there's actually, on the picture of Jupiter, you can see here, there's kind of a big red dot. And that's actually a giant, giant storm that's been raging for pretty much ever, we think. It's always been there as long as humans have seen Jupiter. And it's I think it's like a big red storm that's been going on for a super long time because it has an atmosphere. Okay, so now I'm going to tell you what you really want to know about, which is black holes. So this is a picture of kind of what a black hole looks like. What a black hole is a region of space and time where the gravity is so strong and so powerful that no particles or even light can escape from it. So as I said before, as things get bigger, they have more gravity. But in this case, something got big and it had so much gravity that it crushed everything down really compact. And now it's sucking in everything around it. So it's so strong that it's even sucking in light. And as soon as something gets close to the black hole, it cannot escape. The gravity is too strong and it just goes and gets sucked in. So the theory that is kind of behind this is called relativity. And you guys might have heard that in conjunction with Einstein, with Albert Einstein's name. And he kind of predicted that if a mass or a physical body got so compacted that it would actually distort the space around it. So what happens is, if you're thinking of these parts of space being a little bit flat, they go and get crunched down all around the black hole. And so there's a couple different important parts of this, and I wanted to show you this picture because I think it's really detailed. In the boundary around the outside where nothing can escape from the black hole is called the event horizon. So as soon as another planet or maybe a piece of space junk or even light get onto that black horizon, there's no escape possible. They're just getting sucked right in there and then crushed. And because this has a lot of effect on all the objects that are floating around in space, it's really difficult to kind of describe it and detect it. Because as you can imagine, if we were trying to take a camera out to take a picture of the black hole, if we got too close, what would happen to our camera? It gets sucked in, yeah, and then it gets squished down. Yeah.
Megan,
Yeah.
but where does everything go? If it's
That's a really good question. So we're actually not really sure where everything goes. We know that it gets crushed down really, really tight, but we actually don't know what's kind of in the bottom of that black hole because there's really no way to tell. So we know that the light and everything gets sucked in and then it can't be reflected, and that's why it's so black. But I think there's some mathematical and physics theories about what's actually in there, but not sure. I can look into it for you, but there are some very intensive fields of study called like quantum physics and things where they're trying to explain this right now. But the short answer is that we're not really sure at this point. I can tell you also that because all the light and the heat and everything is getting sucked into this black hole, we do think that it's really, really, really hot in there. So while everything's getting sucked down in there, we think it's like billions of degrees in these black holes. So if there's stuff in there, it might be all burnt up as well. And I mentioned before that there's some discoveries that are behind this, and you guys probably know the guy that's in the center picture here. That is Albert Einstein, and he kind of developed some of the theories behind this in the early 1900s.
I have a question.
Sure.
So what happens if the Earth gets sucked into a black hole?
If the Earth got sucked into a black hole, I think we would kind of be in trouble, right? Because it sucks in all the light and all the heat and everything, and then it crushes it down. So I think, unfortunately, our planet would no longer exist. But luckily, there are no black holes close to us, so we're pretty safe as far as that. Yeah.
How big are they? The black holes.
They actually range in size depending on how big the explosion was that has created them. So they can be like really, really big, bigger than our sun, or they can be a little bit smaller. But I do think they keep growing as they're pulling more items in, because as you can imagine, before I said that the amount of mass that they have depends, or the gravity depends on the amount of mass. So as they're pulling in more mass, they're actually growing. So one of the first people that actually kind of thought of this and described it, which I think is really cool, was this man named Mitchell. And this was back in the 1700s. John Mitchell in the late 1700s. He's this guy over here with the funny necktie. And he was actually a pastor, and he was interested in a bunch of different fields of science. And he published a letter with some calculations where he thought that there might be some things that are similar to black holes, but the term black hole wasn't coined until later in the last century. So along with Albert Einstein, this other guy that I put in the picture, he also helped you describe some of it. And there are, his name is Oppenheimer, by the way, and he co-authored a couple papers about it, but there's a few different people just in the last century that have made really, really great strides in understanding black holes, but they've done most of it via mathematics and physics. And I am not very good at physics, so I don't understand a ton of it. So I do want to show you a very cool discovery that happened just in the last year. And we actually got our first photograph of a black hole in the last year, and this is it. So even though the idea of the black hole was first proposed in like the 18th century, we are just getting pictures of it now. So I thought this picture was really cool. This is from NASA, and it was just published last year. So I want to tell you a couple of cool facts about black holes. So one is that they can have the mass of several million suns. So when you were asking about size, mass isn't traditional size. It's more about the amount of the object in there, and it does get crushed down, but it can have the mass of several million suns. And they also don't last forever, but they're kind of slowly evaporating. And so all of their energy and their matter is going to get returned to the universe eventually and broken down. Also the center point where it's like at its most dense is called the singularity. So I thought that was quite interesting because it sounds like a very sci-fi term. And they're also all different in how much mass they have and even in their spin. So they can be pretty similar in other effects, but they might all spin a little bit differently. And then the other thing is that the ones that we know about tend to fit into two different categories on size, and that's stellar, and those are about the mass of one sun, and then supermassive are the mass of like several million stars. So we kind of put them into two different categories of sizes. And the next thing I wanted to do is actually show you guys a cool video that I found about them. And I need to just make sure that my settings are correct here. So just one moment. And let's see, share screen. Whoops. I think you guys, I'll move this here. Yes.
Can they move?
Can they move? Yes, they are moving a little bit in space, actually, which I think is quite interesting. They're moving around, but they're not really going to chase us or anything, which I think is very important to know, that they're not coming after us or anything. Okay.
And what would happen if it sucks the sun?
If it sucked our sun in, the sun would get crushed down along with all the other stars and things. And I think at that point, if it was close enough to suck the sun in, it would probably also suck the earth in. And kind of crush everything. So remember, it takes in all the light and the heat and the energy and the mass. But luckily, there aren't any close to us, so we're safe. Okay, so I'm going to go ahead and play this video for you guys from NASA.
Space place. In a snap. What is a black hole? Space is a pretty dark place. Even so, some areas are darker than others. Nothing is darker than a black hole. A black hole is an area of such immense gravity that nothing, not even light, can escape from it. Black holes form at the end of some stars' lives. The energy that held the star together disappears and it collapses in on itself, producing a magnificent explosion. Here's where things get crazy. All of that material left over from the explosion, many times the mass of our sun, falls into an infinitely small point. Black holes can form in many ways though, and large black holes can have tens to millions of times the mass of our sun trapped in a point smaller than the tip of a pin. Some black holes trap more and more material as their mass increases. The point where all that mass is trapped is called a singularity. It may be infinitely small, but its influence is enormous. Imagine a circle with a singularity in the middle. The gravity on the inside of the circle is so strong that nothing can escape. It sucks in everything, even light. That's why it's black. This circle is known as the event horizon. An event horizon is probably what you are thinking of when you think of a black hole. What would happen, you might wonder, if we took a spacecraft near a black hole's event horizon? The answer? Spaghettification. That's the technical term at least. As our spacecraft approaches, the gravity will be so much stronger on the side closer to the black hole than at the other side that it will get completely stretched out like a piece of spaghetti. Try as you may, you would be hard-pressed to find anything weirder or cooler than a black hole. Presented by NASA's Space Place.
So I hope you guys enjoyed that video. I thought it was really neat. And NASA's Space Place actually has a bunch of very cool different things for you guys. And I've got some of the, let's share this again, presenter view. There's actually quite a few different resources for you that I will show you in just a moment. So for today's homework, little kids can choose a picture to draw. As always, you can draw me a black hole, you can draw space debris, or you can draw a galaxy. For bigger kids, you can draw a picture of a black hole and its gravity, or its gravity field around it. You can make a comic about space and what black holes do, or you can write a few sentences about how black holes were discovered. Finally, for middle schoolers, you can write a paragraph explaining who described and proved black holes. You can draw your own diagram of space, or you can create a comic about gravity. And then, as always, you can email your homework to me, and the company that I work for, Scientist.com, will pay for a $10 Amazon gift card for whoever wins, or approximately €9.25 for Inez and Carmen if they win. And there are lots more resources here, and I will email these to you. So NASA has a really cool kids club and a space place where you can explore and do activities. And then the European Space Agency also has a couple cool resources for you guys. So I hope that you found this helpful and interesting. You guys had great questions today, and I really appreciate it.
Yeah.
Yeah.